Fourth grade into math, lesson 10.2, identify factors. So yesterday we did factors and we did our rainbow, right? And then we identified the factors and then decided what could go together, correct? Okay, and we did arrays. And then factors are the numbers that make up a multiplication equation, okay? And then of course the product is the answer of that multiplication equation. I can use division to determine whether a number is a factor of another number. Spark your learning. Mrs. Aisha owns a bakery. She wants to put all of these blueberry muffins in a display case with the same number of muffins on each shelf. Which display case should Miss Aisha use? Okay, so first of all, we have to figure out how many muffins there are. So how many total muffins are there? There's 16 muffins, right? Okay. Now, if I would go and do my 16, so I'm going to put a little X in each box. So 1, 2, 3. And we need 3 rows, right? Because 3 rows is how many shelves you have. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Does that give me an equal amount on each one? No. Okay, let's try the 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Does that give us an equal amount? Yes. Yes. Okay, so which shelves would work better, the 3 shelves or the 4 shelves? 4. Okay, now, without drawing a picture like that or an array like that, what could I also have done? I could have done 16 divided by 4, or I should know that 4 is a multiple of 16, but is 3 a multiple of 16? No. So automatically I should have known that without having to draw a picture, right? Or 4 is a factor of 16. If I took 4 times 4, do I get 16? Right. Can I take some number times 3 as a factor to get 16? No. Builder receiving number 1. Mrs. Aisha builds a new kind of granola bar for her customers to try. Or she makes one, sorry. She wants to display 40 bars in equal rows on a tray. Can Miss Aisha place all the bars in 5 equal rows? So before we even start, is 5 a factor or multiple of 40? Yes. Okay. Could it be a multiple of 40? No, because multiples go 40, 80, right? So it could be a factor, right? Okay, so let's double check and see, because what times 5 would get us 40? 8. So let's see if we can prove that. So we're going to go 1. Okay, so we did our 5 equal rows until we got to 40 with our X's. And then how many columns did we get, guys? 8. So did we prove that 5 times 8 gets you 40? Yep. And would she be able to place them in all equal rows? Yes. Okay, so what shape does your visual model show? Circle? A rectangle, right? What does the shape tell you about whether or not all the granola bars can be placed in equal rows? So, do we have an extra one just hanging out there somewhere? No. So, did it, since it's in a very consistent shape, does that mean that they can have an equal number on each shelf? Or in each row? Yeah. And I should put all the granola bars in 5 rows. Yeah, and we just said because we don't have any extra that are in one of the rows, correct? Okay, so is 5 a factor of 40? So yes, because, did we have any left over? Okay, because we didn't have any rows with a different number. Number 2, Mrs. Aisha has 35 loaves of French bread. She wants to put the same none left over. Can you use the division problem to solve, or can you use the division problem? Yes. Okay. So basically, when we were putting all our x's out in an array, were we dividing them into different rows? Yes. Okay. So you were dividing just in a different way. Okay. So let's look. 3 can go into 3 how many times? One time. And use the boxes to help keep things in line. 3 times 3, or 3 times 1 is 3. Oh, we forgot to put our steps. Divide, multiply, subtract, bring down. Okay, so I divided, I multiplied, now I need to subtract. 3 minus 3 is 0. Now I bring down the 5. How many times does 3 go into 5? One time. 1 times 3 is 3. 5 minus 3 is 2. So 11, remainder 2. So can all of the 11s be put in 3 baskets with the same number in each one? No, why not? Because you have a remainder of 2. So you could put 11 in each one and be equal, right? Okay, but if you wanted to use all of them, you would have 2 baskets that have 12 loaves and 1 basket that has 11, correct? Okay, so is 3 a factor of 35? No, why not? Because we had a remainder of 2 left over, correct? Okay. So a factor of a number divides that number evenly. The quotient is a whole number and the remainder is 0, so we put it, right? Because we had a remainder. Step it out, number 3. Is 6 a factor of 84? So they do have divisibility rules so that you don't have to do the box and everything else, okay? So a number is divisible by a second number if the quotient is a whole number and the remainder is 0. So if a number is divisible by something, then blank is a factor of that number. So basically, you just can't have a remainder, right, for it to be divisible by that number. Okay, so up here, they gave us the divisibility rules. Okay, 2, it can be divisible by 2 if the number is even. 3, the sum of the digits is divisible by 3. The last 2 digits form a number that is divisible by 4. The last digit is 0 or 5, and the number is divisible by 2 or 3. Okay, and then the sum of the digits is divisible by 9. So is 84 divisible by 2? So is 84 an even number? Yeah. So yes. Is 84 divisible by 3? So we go back up here and we look at our rules. The sum of the digits is divisible by 3. So what is 8 plus 4? 12. Is 12 a multiple of 3? Yes. So it would be easily divisible. Is 84 divisible by 6? Yes. The number is divisible by 2 and 3. So we go back up to the rule for 2 and 3. So 2, the number is even. Is it even? Yes. Yep. And then did it work for the sum of the digits is divisible by 3? Yes. So would 84 be? Yes. Is 6 a factor of 84? No. You can't take 6 times something to get 84. Okay, so yes, because 6 times what equals 84? What do you guys think? 14. Because you would mentally say 6 can go into 8 one time, right? 8 minus 6 is 2. Bring down the 4. 6 can go into 24 4 times, and then you have nothing left over. Second student, Miss Anisha wants to put Vegemite bagels in bins with the same number in each bin. Should she use the 3 or 4 bins? Use factors to justify your answer. So if we go up here to our factors, the divisibility rules, okay? So for 3, it says the sum of the digits is divisible by 3. So 5 plus 1 is what? 6. Is that divisible by 3? Yes. Yes, so 3 would work. The divisibility for 4. The last 2 digits form a number that is divisible by 4. So, could 51 work for 4? No. So she would need to use 3 bins because, okay, so we went ahead and wrote that our reasoning was 5 plus 1 is 6, which 6 divided by 3 is 2 with no remainder, which of course the no remainder is the biggest key to figuring out which one would work best, correct? On your own, there are 26 members in the marching band. How can the members march in 4 equal rows? Use square tiles to represent the problem, then draw an array to show your work. Okay, so we drew our 26 X's and we used 4 rows. So can 26 band members march in 4 equal rows? Okay, no, because we have how many left over or remainder? We have a remainder of 2. So they're not equal rows, right? Okay. Okay, so for number 3, we put our 32 X's out. We had 5 completely full columns, and then we had 2 left over in the last column that wasn't a complete one. So we said no, 6 would not be a factor of 32 because you would get 5 remainder 2, and since you have a remainder, that would not get you an even number. Okay? Number 4. Okay, so we had our 25 X's. We put them in the 5 rows. And then we said, yes, 5 would be a factor of 25 because if you take 25 divided by 5, you get 5 with no remainder. You get an even number. Number 5, explain whether or not the following statement is true. Since 89 is not divisible by 2, then 89 is not divisible by any multiple of 2. Okay, so we said yes because any multiple of 2 would be an even number as well. So 89 is always going to be an odd number, so it has to be divisible by an even number if it would work for 2, right? Or any multiple of 2. Okay, so we marked off number 6 just because of time. We're going to do number 7. Is 7 a factor of 9? So they want us to divide it out. Okay, so what are we going to do? Our divisibility rules: divide, multiply, subtract, bring down. Okay, so we said we got 13 in our answer, and we said yes, 7 evenly divides into 13. Okay, and we know our multiples of 8 already, so we should know if there's anything times 8 that gets us 94, but let's look. So 1 time minus 8, 1 left over, bring down the 4. How many times does 8 go into 14? 1 minus 8, 6 left over. So would it work? So no. We have a remainder of 6. So no, it is not a factor of 94, right? Okay. All right, use the divisibility rule to answer the following. 9, is 5 a factor of 80? So what's the divisibility rules for 5? The number has to end in a 0 or a flat. So would that be a factor? Yes. 80 ends in a 0, right? Okay. Number 10, is 9 a factor of 88? So look back to this page. What was our rule for 9? The sum of the digits is divisible by 9. So what is 8 plus 8? 16. Is 16 a multiple of 9? No. So no. 8 plus 8 equals 16. And 16 is not a multiple of 9.